Page 13 of integration. Start with this one here. Remember, we just treat these as two separate terms. So the integral of x would just be x squared over 2. The integral of negative 5 over 1 minus x. This looks like it would be a log because the integral of 1 over x would be log x, right? So this looks like it would be a negative 5 log of 1 minus x. Okay, because if we took the derivative of 1 minus x, it would be 1 over 1 minus x, and then we do the chain rule. We multiply it times negative 1, which is the derivative of 1 minus x. In this case, we need to get it ready for the chain rule, so we would just divide by negative 1 so that we would cancel out the negative 1 that's going to come out the chain rule, so we just put plus. So let's test it out now. Let's take the derivative of 5 log of 1 minus x. We'll get 5 1 over 1 minus x times negative 1. So that would give us a negative 5 over 1 minus x. And that's exactly what we have here, so I think that's fine. And then, of course, we need to add the integration constant, plus c. Okay, moving on. Number 7. Find y given that the derivative of y is this. It's just another way of saying, hey, take the integral of 1 minus e to the x squared. Remember that it's kind of hard to take derivatives of functions inside functions. We could try, but no, I don't think we want to. In this case, let's say that we were going to try to use the power rule, and then we say, oh, then it should be 1 minus e to the x cubed over 3. But then if we were to take the derivative of this, then remember that it would be, oh, we put 3, 1 minus e to the x squared divided by 3, and it looks like it's okay, but then remember we've got the chain rule, be negative e to the x, and there's no negative e to the x there. So forget that. Don't try to do that. Okay? The best thing to do is to multiply everything out. Multiply everything out, make separate terms, and then it will be 3 simple integrals instead of 1 complicated one. So if you have something squared, you use FOIL, right? So the first term would be 1. The last term would be e to the x squared, which would be the same thing as e to the 2x. It would be positive because 2 negatives multiplied times each other gives a positive. The outer and the inner terms would just be negative 2e to the x. So this is not so hard to take the integral of, right? Take the integral of 1, it would be x. Take the integral of negative 2e to the x, it would be negative 2e to the x. The derivative of e to the 2x would just be e to the 2x divided by 2. And then, of course, you add the integration constant. Okay, I think that's all right. Now what about this one? The integral of e to the negative 2x would just be e to the negative 2x divided by negative 2. The derivative of 4 over 2 to the x minus 1, this would be a log, right? A log of 2x minus 1. We would divide by 2 in preparation for the a coefficient to come out of ax plus b. Remember, this would be ax plus b. And we would put a down here, which would be the 2. Okay. Plus. And then, of course, add the integration constant. Number 9. Suppose that f dash equals p sine of 1/2 x, where p is a constant, f of 0 equals 1, f of 2 pi equals 0. Find p and hence f of x. The reason why they're giving you these is because they want you to take the integration constant c and find a specific number for it, which we'll be able to do with these two given points. So basically what we're going to do here is we'll find the integral of p sine of 1/2 x the integral of sine is negative cosine, because remember the derivative of cosine would be negative sine. So we're going to put here negative cosine of 1/2 x, and the a coefficient is 1/2. So we're going to divide by 1/2. And, oh, don't forget about p. P is a coefficient that's multiplied out front, so we'll put it out front like that. Okay, so I think that's the answer. Let's just test it. We'll take the derivative of that and see if it actually works. So the derivative of cosine would be negative sine of 1/2 x. So the negatives would cancel out. And then we would have p out here. And we would have 1/2 out here, because the chain rule would put the 1/2 out here, and then we also have a 1/2 on the bottom, so the 1/2s cancel out, and we end up with p times sine of 1/2 x, which is exactly what we wanted to start out with. So it looks like that is an okay solution. And of course we put the integration constant. Let's just simplify a little bit, because we can instead of dividing by 1/2, we can multiply by 2. So we'll have negative 2p cosine of 1/2 x plus c. And then we'll check, okay, what about when x equals 0 and y equals 1? So we'll try that. So y equals 1. And that'll be negative 2p cosine of 1/2 of 0, so that'd be 0. Plus c. And then the other point would be 2 pi, the x would be 2 pi and y would be 0. So this point would yield 0 equals negative 2p cosine of 1/2 of 2 pi, which would just be cosine of pi, plus c. Cosine of pi would be negative 1, so that would be 0 equals negative 2p times negative 1 plus c, so that's equal to 0 equals 2p plus c. And then this top one, 1 equals negative 2p plus c, we can write that out too. Okay, so we have one equation that looks like that. We have one equation that looks like that. Let's see, let's solve for c here. So c equals negative 2p. Okay, and so let's put that into this one, and we'll have 1 equals negative 2p, and c, remember, is negative 2p also. So 1 is equal to negative 4p, so p is equal to negative 1/4. Okay, and if p is negative 1/4, then c equals negative 2p, so c is equal to positive 1/2. Okay, so the equation is going to be, is it going to be p, which is negative 1/4, times times cosine, right? I'm substituting into this one here. Times cosine of 1/2 x divided by 1/2, which is multiplying by 2, plus c, which is 1/2. And you can see that we can also change 2/4 to 1/2 too. A lot of 1/2s in that. Okay. 11. Find f of x given that the derivative of f is equal to 2e to the negative 2x, and f of 0 equals 3. So remember, the derivative of this, or the integral of this, would look kind of like that. It would be 2e to the negative 2x. You just divided by the a constant, which would be here, negative 2. So that's equal to negative e to the negative 2x. Yuck. Let me rewrite that. Negative e to the negative 2x. So that's my f of x plus c, right? That's my f of x. And so if this is my f of x, if I substitute x equals 0, then I should get y equals 3. So I'll put 3 equals negative e to the 0 plus c, which is equal to negative 1 plus c. So c is equal to, I'm going to add 1 to both sides, equals 4. So it's equal to, the function is equal to negative e to the negative 2x plus 4. Okay. C. A curve has a gradient function square root of x plus 1/2 e to the negative 4x and passes through 1, 0. Find the equation of the function. So if a curve has a gradient function of this, then that kind of means that it's the derivative function of the original function f. So once again, it's just another way of asking to do the integral. So we're going to rewrite this as x to the 1/2 plus 1/2 e to the negative 4x. Let's take the integral of this. We're going to get x to the 3/2 times 2/3. We're going to get, we'll put 1/2 out front, and then the integral of e to the negative 4x would be e to the negative 4x divided by negative 4. And then we would add c at the end. So that's equal to y. And then if y is 0, x is 1. So let's substitute in 1 here. So 2/3 times 1 to the 3/2 is 1, plus 1/2 e to the negative 4x, and x would be 1, and so that would be e to the negative 4, e to the negative 4, and that's all divided by negative 4, and that's added to plus c, and that's equal to 0. Let's try to simplify this. So it would be 2/3 plus e to the negative 4th divided by negative 8. 2/3. Yuck. Due to technical problems, I'm using my old iPad, and I think it's even worse than the new iPad. Okay, so this is equal to 0. Oops, plus c is equal to 0. So let's leave c on the left, and then we'll move everything else to the right. So c would be negative 2/3 plus e to the negative 4th over 8. Okay, so this would be the constant term there. Or actually here. So this c term is equal to this. Alright. Moving on. 13. Show that cosine of x plus 1, quantity squared, is equal to 1/2 times cosine 2x plus 2 cosine of x plus 3/2. Hence determine the integral of cosine x plus 1 squared. Okay, so if you have this binomial squared, then the first thing you want to do probably is FOIL. So let's do FOIL. We'll get cosine squared x for the first terms. We'll have plus 1 for the last terms. And then the inside and outside terms would be plus 2 cosine of x. Do you notice that here, cosine 2x, that's kind of weird. Where did that pop out from? All we have is cosine x here. Well, remember that there's an identity we used on the previous page where cosine squared of x is actually also equal to, and this is from a previous chapter that we did on trig identities, it's equal to this. So that is actually equal to that. So since that's true, let's do a substitution and see what we get now. Okay, so now we can see that we have a 1/2 and we have a 1. Those can be combined to be 3/2, and then everything else is exactly as it should be here, right? Okay, so we have shown that. Now determine that. Now determine the integral of cosine x plus 1 quantity squared. Well, we know that cosine x plus 1 quantity squared is now this expression, right? So now all we need to do is take the and let's just combine the 1/2 and the 1. We make 3/2, right? But let's just take the integral of each one of these terms. Now that it's a bunch of single terms, it's a lot easier to take. There's nothing squared here, so it's easier to take the integral. So, for example, the integral of cosine 2x would be sine of 2x. It's got a coefficient of 1/2 out front, and then we need to prepare for the a coefficient here by multiplying by an additional 1 over a. What about the 1/2 and the 1? Those get put together. They make 3/2. When we take the integral of 3/2, it's 3/2 x. And finally, we have 2 cosine of x. The integral of 2 cosine x would just be 2 sine of x. And there's no chain rule because the inside of sine, there's just an x there. So finally, there's a c integration constant. Now the 1/2 multiplied to each other here can be combined into a 1/4, right? Otherwise, that's it. 18G, integration by substitution. Making sure to use the chain rule, find the derivative of that. Okay, so let's do that. It's pretty messy, but basically you have a power function. So the power is going to bring a 5 out the front, and then it's going to be x squared plus 3x to the 4th, and then we use the chain rule. It's going to be 2x plus 3. Okay, so basically it's going to be x squared plus 3x to the 4th times 2x plus 3. The 5 over 5 cancels out, becomes 1. What is the u substitution you make for the chain rule? Well, the u substitution here, remember that first we did the power rule. So the inside of this function is the substitution we make. So basically we start out with 1/5 u to the 5th, and then we take the integral of that. So u is equal to x squared plus 3x. That's the substitution we make. And then let's move on to page 14. Now it should be easy to find the integral of this complex function. So they give us this function. Part of it is this, right? 2x plus 3 here, 2x plus 3 here. And the rest of it is the u to the 4th here, okay? So the derivative, or the original function, would just be 1/5 x squared plus 3x to the 5th, right? Because we took the derivative of that and we got this function. All right. Oh, remember that we need to put plus c always. Did I miss any of those in the previous page? Any plus c's? I think I got them all. All right. So you can do some complex integrals by reversing the chain rule. Now, use the substitutions given to perform the integration. So they're being nice to us. They're actually giving us the u substitution that needs to be done here, even though it's kind of obvious. I mean, especially since they're book problems. So if you have this as the u substitution, looks like it's a power rule that you're going to have to do. So you're going to put u to the 5th over 5, and then you're going to have du dx. What is du dx, by the way? Du dx is equal to 3x squared, and the 1 just goes to 0. Hey, look, 3x squared, there it is. So this matches perfectly. That's du dx. That's du dx, and then this is u to the 4th. So let me